take a look at this problem. It says construct a 95% confidence interval for mu sub 1 minus mu sub 2. So the differences between the first population and the second population, or the first population slash sample and the second population slash sample. Okay, so two samples are randomly selected from each population. The sample statistics are given below. So we've got N1, X bar 1, S1. Excuse the horrific notation here, but it just wasn't very easy to make subscripts in here. So, okay. Well, first off, nowhere do I see sigma given, so that tells me exactly which one to use. So I come over to my calculator, do a clear. I go to stat. I'm gonna go to tests. These first one are for hypothesis testing, so you can skip over those. We want the ones that end with intervals on INT. And specifically, the ones we're looking at is the 2. That means 2 population, 2 samples. So 2 samp z-int, 2 samp t-int, and 2 prop z-int. Now the 2 prop z-int is for proportion, so that one's pretty easy to see when to use. The 2 samp z-test and 2 samp t-int are both for mean. Now the z-int is if sigma is given. T-int is sigma is not given. Well, nowhere in this problem are we given sigma, so we want to use 2 samp t-int. So I choose that. Data is when you're given raw data. Stats is when you're given summary statistics. We got summary statistics, so I'm going to go over to stats and press enter on it. Now it'll ask us for X bar 1, which was 25. It'll ask us for SX1, which is our S1, which is 1.5. And it'll ask us for N1, which is 50. Then X bar 2, which was 23. Then SX2, which is 1.9. And then N2, which is 60. C level says construct a 95% confidence interval, so I put in 0.95. Now when you get down to pooled, we'll always put a no here unless the population variances of the two populations are equal. Well, nowhere does it say anything about that, so we'll leave that as no. Then I come down to calculate. And we're going to round this to 3 decimal places. So we got 1.357, comma 2.643. Now the reason why that's 3 is because this is 5 or greater, so I round up. That becomes a 0.643. Over here, this was less than 5, so I rounded down and just stayed the 1.357. But that would be our answer.